the steel didn't forgive mistakes. Up there, one wrong step didn't slow you down, it removed you. There were no second chances at that height. No barriers, no nets, nothing to catch you if your foot slipped or your hand missed its grip by even an inch. Just air. Hundreds of feet of it. Men walked narrow beams the width of a boot, carrying tools, hot steel, and sometimes nothing but their own balance. The wind didn't care who they were. The machine didn't care how experienced they were. If something went wrong, it happened fast. And once it started, it didn't stop. This wasn't normal construction. It couldn't be, because everything about this project was pushed beyond what should have been possible. The height, the speed, the coordination, every part of it depended on precision that humans aren't built to maintain for long. And yet, thousands of workers showed up every day and stepped onto that steel. Not because it was safe, because it was necessary. Midway through all of this, March 17, 1930, Manhattan wasn't looking at a building, it was looking at a system. A structure rising so quickly it didn't feel real. Steel climbing upward day after day, floor after floor, faster than anything anyone had seen before. From the street, it looked controlled, organized, efficient. But inside that structure, it felt different. Because nothing was being built in the usual order. Everything was happening at once. Foundations, steel, materials, machines, all moving together in a way that left no room for delay. If one part slowed down, the entire system felt it immediately. So it couldn't slow down. That pressure didn't just sit in the machines, it sat in the people. Paul Starrett, the man leading it, had already made a decision that defined everything that followed. He told investors he didn't have the equipment for a project this size, and instead of adjusting the plan, he removed the limits. New machines were built, new systems created, everything redesigned around one idea: speed. Because this wasn't just about building something tall, it was about building it before anyone else could. There was already a race happening across the city, towers competing for height, each one trying to outdo the last. And in that race, hesitation meant losing. So Starrett didn't hesitate. He built a process that moved continuously, materials arriving exactly when needed, machines lifting steel without pause, workers adapting to a pace that didn't allow mistakes. But that kind of system comes with a cost. At the time, there was a rule in construction. For every $1 million spent, one worker would die. This project cost over $40 million. Everyone knew what that meant. The numbers didn't lie. And yet, the work continued. So the question isn't just how this building was completed in 410 days. The real question is, how do you run a system this fast, this high, this dangerous, without it breaking? This wasn't just a competition. It was a race where losing meant disappearing. Across Manhattan, buildings weren't being designed anymore. They were being pushed higher, faster, riskier, just to stay ahead. Height had become power, and once that happened, logic stopped mattering. One tower had already claimed the crown. On paper, it was unbeatable. Its height was calculated, finalized, announced. Investors were confident. The race was over. Or at least that's what everyone thought. Then something changed. Not gradually, not publicly. Silently. Inside another building, hidden behind steel and walls, a structure was being assembled in secret, floor by floor, piece by piece. No announcements, no attention. And then in less than 2 hours, it appeared. A massive steel spire lifted from inside the building and locked into place at the top. Just like that, the skyline changed. The tallest building in the world replaced overnight. No warning, no chance to react. From the street, people didn't fully understand what had happened, but the men behind the next project did. Because now they knew something dangerous. You couldn't trust what you saw anymore. Any building could grow taller at any moment. Any competitor could be hiding something. And that kind of uncertainty changes decisions fast. John Raskob didn't want to build a tall building anymore. He wanted to build something no one could beat. So he asked a simple question. How high can we go before it becomes impossible? The answer should have stopped the project. Instead, it pushed it further. The design didn't just increase, it stretched. Floors were added, height extended, limits ignored. And then came the final move, a mast at the top. Not for function, not for safety, for height. It was supposed to dock airships, but it never really worked. The wind at that height was too violent, too unpredictable. Even standing there was difficult. But that didn't matter, because the mast wasn't built for use. It was built to win. And once that decision was made, everything changed. Now the problem wasn't design. It was execution. Because building something that tall isn't just difficult, it's unstable. The higher you go, the more everything starts to fight back. Wind doesn't push, it pulls. Steel doesn't just hold, it bends. Loads don't just sit, they shift. And every extra foot adds pressure. Not just on the structure, but on the system that builds it. To reach that height, building codes had to change. Limits on steel strength increased. Elevator speeds pushed beyond previous safety standards. The building wasn't adapting to the system. The system was being forced to adapt to the building. And that's where the real danger begins. Because once you remove limits, you don't just build higher, you build closer to failure. And now the question wasn't just who would win the race. It was something more uncomfortable. How far can you push a machine before it stops being controllable? Before anything could rise, everything below had to disappear. On that site stood one of the most famous hotels in New York. Heavy stone walls, steel skeleton, years of history built into every layer. Normally, a project like this would take its time. Demolition first, then clearing, then excavation, then foundation, step by step, controlled. But this project didn't follow that logic. It couldn't, because time wasn't something they had. So instead of waiting, they overlapped everything. While one part of the building was still being torn apart, another part of the ground was already being drilled. You had workers breaking walls on one side and others digging deep into the earth just a few feet away. Two completely different operations running at the same time. It shouldn't have worked, but that was the system. Nothing waited for anything else. Below the surface, the real challenge began. This wasn't just digging dirt, this was New York. Layers of fill, compacted soil, glacial debris, and somewhere beneath all of it, solid bedrock. That's what they needed, because without that, everything above would eventually collapse. Workers dug deeper and deeper, removing tens of thousands of tons of earth. Heavy material pulled out continuously without slowing the work above. At around 55 feet down, they reached it. Manhattan schist. Hard, dense, stable. The only thing strong enough to carry what was coming. But reaching it didn't make things safe. It made them heavier. Because now the real load could begin. Concrete shafts were drilled into that rock, dozens of them. Each one designed to carry massive weight. Some of the main columns alone would support millions of pounds once the building was complete. That kind of pressure doesn't allow mistakes. If a single foundation point failed, everything above it would be at risk. And here's where the system became even more aggressive. They didn't wait for the entire foundation to finish. The moment a section was ready, steel started going up, columns rising while other parts were still being drilled. It wasn't a sequence anymore. It was a chain. Every completed piece immediately triggered the next step. And that created something dangerous: momentum. Because once momentum builds in a system like this, you can't stop it easily. If you slow down, everything behind it piles up. If you make a mistake, Fixing it takes time the system doesn't have. So instead, you keep moving. Even if conditions aren't perfect, even if parts aren't fully ready, even if the margin for error is shrinking. From above, it looked efficient. From the street, it looked organized. But inside the process, it was something else. Workers weren't just building anymore, they were keeping up. Keeping up with machines, keeping up with schedules, keeping up with a system that didn't pause. And that pressure didn't stay in the ground, it moved upward. Because once the foundation started, everything above it had to match its speed. And at that pace, the question wasn't whether the building would rise. The question was how much strain the system could take before something finally gave way. The building didn't rise on its own. It was lifted, piece by piece, by machines that were never meant to work this hard, this high, or this fast. At the center of everything were the derricks, tall, skeletal structures anchored into the steel frame itself. From a distance, they looked simple, just masts with cables and a swinging boom. But up close, they were something else. Each one controlled tons of steel suspended in the air. And once a load was lifted, it couldn't hesitate. Because hesitation at that height didn't mean delay, it meant instability. A single beam could weigh up to 30 tons, hanging hundreds of feet above the street, moving slowly but never truly still. The wind didn't stop for it. At higher floors, the air moved differently, not steady, but shifting. Gusts would catch the steel and turn it into a pendulum, a heavy, uncontrollable swing. And when that happened, the machine didn't correct it. The operator had to. Every movement was manual, levers controlling cable speed, brakes holding tension. No automation, no backup systems, just judgment. And if that judgment was even slightly off, the steel didn't forgive it. But the biggest problem wasn't the weight, it was the height. A derrick could only lift so far, and this building kept going. So they created something new, a relay system. Instead of lifting steel directly to the top, they passed it upward in stages. One derrick lifted the beam to a platform, another took it higher, another finished the job. Like a chain, each link depending on the one before it. It worked, but it also multiplied the risk, because now a single mistake didn't affect one lift, it affected the entire sequence. If one derrick operator misjudged timing, the next one received an unstable load. If the cable speed wasn't controlled perfectly, the beam could swing, and once it started swinging, stopping it wasn't immediate. Below them, Manhattan didn't stop either. Traffic moved, people walked, the city continued, unaware of what was happening above. Because from the ground it looked controlled, steel rising steadily into the sky. But inside the system, it was constant tension, constant correction, constant risk. 17 hoists ran at the same time, feeding materials upward, each one adding to the load, the movement, the pressure. The building wasn't just being constructed, it was being assembled in mid-air. And the machines weren't supporting the process, they were defining it. Everything depended on them, their speed, their coordination, their limits. And those limits were being pushed every single day. Because stopping wasn't an option, waiting wasn't an option. The system had to keep moving. Even when the wind picked up, even when loads became unstable, even when the margin for error disappeared. Because once a machine like this is in motion, it doesn't slow down easily. It just keeps going until something forces it to stop. The machines didn't build the structure alone. They couldn't, because every movement, every connection, every piece of steel that locked into place passed through human hands. And those hands were working at heights where hesitation didn't exist. If the derricks were the spine of the system, then the riveting gangs were its heartbeat. Everything depended on them. Steel beams could be lifted into position, but they didn't hold until the rivets were set. And that process was fast. Not because it was safe, because it had to match the speed of everything else. A typical crew moved like a sequence. One man stood over a small forge, balanced on a plank between beams, coal burning beneath it, heating metal until it glowed. He didn't look down. He didn't need to, because looking down slowed your hands. When the rivet reached the right temperature, he pulled it out with long tongs and threw it, not gently, across open air, sometimes 30, 40, even 50 feet. Another worker caught it, not with his hands, with a tin can. He stood on a narrow beam, body balanced, focus locked. If he missed, the rivet disappeared. If he slipped, he did too. There was no correction, no recovery. Once that moment passed, it was over. From there, the rivet moved quickly, placed into a hole between steel plates, held in place from the other side. And then the hammer came down. A pneumatic gun, heavy, loud, violent. It drove the soft metal into shape, locking the structure together as it cooled. And they did this again and again, hundreds of times a day, thousands across the project. The rhythm never stopped. Noise filled the air constantly, dozens of hammers firing at once. The sound didn't fade, it built. Heat rose from the steel itself, sunlight reflecting off metal surfaces, trapping warmth in the air around them. And beneath it all, nothing, just open space. Workers learned quickly, not through training, through exposure. They stopped reacting to height, stopped thinking about falling, stopped noticing the distance below them. Because thinking about it created hesitation, and hesitation broke the rhythm. But adapting didn't make it safe, it made it normal. That's what changed. The danger didn't go away, it became routine. Men walked beams with tools in one hand and balance in the other. They leaned into moving steel, guiding it into place while it still carried momentum. They trusted each other because they had to. If one man was late, the next step failed. If one movement was off, someone else paid for it. There were no margins, no extra time, no space for error. And the system didn't adjust for that. It didn't slow down when workers got tired. It didn't pause when conditions changed. It kept moving, and the workers moved with it. Because once you're inside a system like that, you're not controlling the pace anymore. You're keeping up with it. From the outside, it looked like construction. From the inside, it felt like a machine. Not one made of steel alone, but of timing. Because nothing on this project worked without precision. Steel didn't just arrive. It arrived exactly when it was needed. Not hours before, not days after. On time. Every beam that reached the site already knew where it was going. Marked, numbered, assigned, floor, position, direction. There was no confusion, because confusion cost time, and time wasn't available. The journey of a single piece of steel started miles away, fabricated in massive plants, loaded onto rail, moved across states, transferred onto barges, then trucks, and finally, into Manhattan. At peak, trucks didn't arrive in groups. They arrived in a sequence, one every minute. If a driver missed his slot, he didn't wait. He came back the next day. That's how tight the system was. There was no space for delay, because once material reached the site, it didn't sit, it moved, straight into the structure. Inside the building, the process didn't slow down, it accelerated. Tracks were laid across floors, small carts ran along them, carrying materials faster than any worker could. Steel, bricks, tools, everything moved through these paths. Not randomly, directed, controlled. Even something as simple as bricks became part of the system. Instead of unloading them on the street, they were dropped into chutes, guided into storage below, then lifted back up through hoists. From truck to placement, without a single unnecessary step. That was the goal. Remove effort, remove delay, remove waste, because every extra movement slowed the machine, and this project couldn't afford that. Even concrete was handled differently. Mixing plants were installed on site. No waiting for deliveries, no traffic delays. Everything produced exactly when needed. The system wasn't reacting, it was predicting. And that's what made it dangerous. Because a system that runs this smoothly depends on everything staying perfect. If one part fails, the rest doesn't stop. It keeps moving. And that creates pressure. Pressure on machines to perform. Pressure on workers to keep pace. Pressure on decisions to be made quickly, not carefully. From above, it looked efficient. From inside, it felt tight, like there was no room to breathe, no room to pause. Because the moment something slowed down, it wasn't just one task affected, it was everything behind it. Waiting, stacking, colliding. So nothing slowed down. Not the deliveries, not the machines, not the people. The building didn't rise step by step, it rose continuously, like an assembly line turned vertical. And once that line starts moving, you don't control it anymore. You stay in sync with it, or you get left behind. By every standard of that time, this project should have been deadly. There was a rule in construction back then. Simple, cold, accepted. For every $1 million spent, one worker would die. No one questioned it. It wasn't written in contracts. It wasn't announced publicly. But everyone in the industry knew it. It was part of the job. The Empire State Building cost over $40 million, which meant one thing. The system expected deaths. Not accidents, not rare events. Expected, calculated. And yet, when the project was finished, the official number didn't match the rule. 5 workers, maybe 6, plus 1 civilian. That's what the record said. And on paper, it looked like something incredible had happened. A project this massive, this fast, this dangerous, and still fewer deaths than expected. But numbers can be clean. Reality rarely is, because nothing about this site suggested safety. There were no helmets, no hard hats protecting heads from falling tools or debris, no safety harnesses keeping workers tied to the structure, no nets stretched below to catch a fall. If you slipped, you didn't get a second chance. You disappeared, hundreds of feet down. And it didn't take much. A misstep on a narrow beam, a shift in balance while carrying weight, a gust of wind at the wrong moment. That was enough. Some workers fell, some were struck by moving materials, some were crushed by equipment that didn't stop in time, and some never made it into official reports. Because record-keeping wasn't perfect, and not every worker had the same visibility. Immigrant labor, temporary crews, injuries that turned fatal later. Not all of them were counted the same way, so the numbers stayed low. But the reality? It's harder to measure. Even the documented deaths tell a different story. Men falling through open elevator shafts, workers hit by hoists carrying steel above them, a laborer struck by equipment and killed instantly, a carpenter losing his footing and dropping into open space, and a civilian walking on the street below, hit by falling debris and dying later from infection. This wasn't controlled risk, it was exposed risk, constant, unprotected. And still, the system didn't slow down. That's what makes this different. Because in most environments, danger forces hesitation. Here, it forced adaptation. Workers learned not to think about it. Not because it wasn't real, because thinking about it slowed them down, and slowing down meant falling behind. So they adjusted. They stopped looking down, stopped reacting to height, stopped questioning the system. And the system continued. Faster, higher, more efficient. But here's the part that doesn't fit cleanly into numbers. The rule said 40 deaths. The records say less. So what does that mean? Did the system become safer? Or did it become better at absorbing risk without stopping? Because safety wasn't added. Nothing about the environment changed. No protections introduced, no new safeguards. Only speed increased. and pressure. Which leads to a harder question. Maybe the system didn't reduce danger. Maybe it redistributed it, spread it across thousands of moments instead of a few large failures. So instead of one big collapse, you had smaller incidents, scattered, individual, less visible, easier to accept, easier to record, or ignore. And by the time the building was complete, the numbers told one story, but the experience of the people inside it told another. In the end, it was finished. 410 days, faster than anyone thought possible. Steel, stone, glass, all locked into place, rising above Manhattan as the tallest structure on Earth. From the outside, it looked like success. Clean lines, perfect height, a symbol of progress. But inside, the story felt different, because when the doors opened, no one came. Most of the building sat empty, floor after floor with no tenants, lights left on just to create the illusion that people were inside. They called it the Empty State Building. The project that broke records couldn't fill its own space. Financially, it struggled. For years. The same system that built it so efficiently couldn't fix what came after. Because speed doesn't guarantee success. It just gets you there faster. And the people who made that speed possible, they didn't stay. Workers moved on to other jobs. Some carried injuries that never fully healed. Some disappeared into the background of other projects. Their names didn't stay with the building. Only the result did. Paul Starrett, the man who drove the system forward, paid his own price. The pressure didn't end when the building was complete. It stayed. In his body, in his mind. He later admitted that the strain broke him. Years of pushing a system beyond its limits finally pushed back. His company didn't survive the years that followed. Bankruptcy came, work slowed. The system that once ran at full speed collapsed under economic pressure. And the machines? They didn't stay either. The derricks that lifted the steel were sold. The rails that carried materials were removed. The tools that shaped millions of rivets disappeared. Nothing remained of the system itself, just the structure it created. And that's what makes this story different. Because when people look at the Empire State Building today, they don't see the process. They see the result. A landmark, a skyline icon, a symbol of ambition. But they don't see the system that built it. A system that didn't stop, didn't slow down, didn't wait for conditions to be perfect. It moved forward, and everything inside it had to move with it. The men didn't have protection. No helmets, no harnesses, no safety nets stretched below them. They had steel under their feet and air beneath that. And somehow, that was enough. At least enough to finish the job. Today, the building still stands. Decades later, unchanged in height, unmatched in speed. But the way it was built hasn't been repeated. Not at that pace, not with that system. Because now we understand something they didn't fully accept then. That pushing a system to its limit always leaves something behind. The Empire State Building didn't just reshape the skyline. It revealed something about progress. That sometimes what we build lasts longer than the people who built it.